Morning, all right.
Get him!
Cheeseburger combo sub and salad. Martin Grill, mini corn dog, bread. For today, congratulations to all of the state students who qualified for our national debate tournament this summer in Louisville, Kentucky, in June. Public Forum, Matt Enzer and Kate Jones. National domestic extent, Joe Moore, Nick Douglas, Sam King, Greg House, and Guy Catori. Congratulations to all of you, and great job representing this high school and preparing yourself for the upcoming state tournament next week. Or if you're interested in joining tennis, sign up in the activities office. Practice March 14th, Coca-Cola. Have more information about upcoming season. Come. Martin Athletic Booster Club Scholarship Fund, and now the activities office is $200 scholarship request. Senior man, book club meets today. Library, copies of the book will be passed out next week. Seniors make sure you check the scholarship database. There's a number of those have been added. If you're interested in Elton Street, from PHSU on March 14th. That deadline is March 7th. If you're interested in law enforcement, South Dakota Control, National Regional Youth Trooper Academy, you must apply for that by March 20th. Also, all junior boys have received an eligible for Boys State. Those applications are due on March 1. Wednesday the 23rd, GSA having a meeting during lunch in this community room. All are welcome today during lunch. All, please stand for the pledge. To the flag. One nation, under God, indivisible, with liberty and justice for all. All have a great day.
Turn those off. You never know who's going to be texting in the middle of class. And just like our last couple examples yesterday, take a peek at example 6. You also had one or two like that in the assignment. Who's still rolling? One or two scratching away. So as of 25 minutes ago, grades should have been locked in for midterm. If I remember right, I think everyone in here is at C or above, so my job isn't to get you out of Spartan time, but I know I ain't the one holding you back, so yay. Y'all doing good. Talked about the grades yesterday. Things look solid. For most folks, it's just a matter of, hey, if you're not sitting at the A you're used to, what are you doing different between this and Algebra 2? Okay, that's a conversation I'm going to have with a lot of parents tomorrow is, well, they've never been at a B. They've never been at a C. What's going wrong? Like, it's not high school math anymore. You might have to ask a couple of questions. I'm starting to get that a little more now. Starting to get that one or two trickle in the morning. Just ask a question for 10 minutes. Hey, I was a little confused by these two. Something on remind. Remember, the more you ask, the better this gets. If I got one kid ask, I'll answer. Two kids, okay, I'll just send you the same response. Third kid asks, I know it's a problem. I'm going to sketch out a video or something, send it to the whole class. Okay? But so far, we don't really have that happening. I want to make sure that you know that is an option. You got a tutor in a pocket. Okay? Even if you're one of those kids that doesn't decide to start working on your stuff until 11:30 at night, A, don't do that. That's not healthy. But B, go ahead, text me. I don't care. I know how to turn my phone to silent. So I'll just answer you at 5:45 in the morning. Okay? All right. If I want to get rid of radicals, and I got two of them, I need to just square as is so that I can isolate one of the radicals. But when I square, I can't square like a freshman. X plus 1 is square the first term, square the second term, and then when I FOIL this out or box method or whatever your jam is, I'm going to have 1 times the radical, then the radical times 1. I'm going to have 2 of that product. Okay, so square, just not like a freshman. You can't just call it 1 plus 2x minus 12 and be done. Okay, then I still have a radical, so I have to isolate this one. 1 minus 12 is negative 11. I'll add 11 over. Subtract 2x over. And I'll do it again. I'll square again, but not like a freshman. Actually, I was walking by Jameson's room the other day, and he's going through polynomials and multiplying binomials with Algebra 1. And just hearing the crickets, he's like, okay, then what's 5 times 15? And it's just nothing, dead silent. Freshman. Okay, square this part, I get x squared. Square this part, I get 144. Multiply and double negative 24x is square this part, square this part. Now you could divide by 2 and then square it, but then you got fractions everywhere. It's easier to just do this and distribute. So we call it x squared minus 24x plus 144 is 8x minus 48. Everyone on one side of the bus because it's a quadratic. X squared minus 32x plus 192. And that was actually what I saw most of us grumbling about. Because we just, what factor is a 192? Hey, if you need to go old school and write it out. 192. I know 2 goes in there. 96. How do you know if 3 goes in there? Y'all remember your divisibility rules?
Isn't the last number like divisible by 3 for the last two?
If you add up the digits. 1 plus 9 is 10. 10 plus 2 is 12. 12 is divisible by 3, so 192 is divisible by 3. It's 64. If the last 2 digits are divisible by 4, then the whole number is divisible by 4, because every time you run into 100, that's divisible by 4. So that's so 20, 50 minus 248. 4 and 48. 5 doesn't end in a 5 or 0. 6, that's 32. 7, no. 8, oh, 24. Okay, and that's the magic ticket. It's x minus 8, x minus 24. So I get this, x is 8 and 24. Hopefully we remembered, because we have an even radical, you could have extraneous solutions, so you got to double check. A plus 1 is 9, square root of 9 is 3. 8 by 2 is 16, 16 minus 12 is 4, square root of 4 is 2, 2 plus 1 is 3. Okay, that works. Try 24. 24 plus 1 is 25, square root of 25 is 5. 24 by 2 is 48, 48 minus 12 is 36. Square root of 36 is 6, but it's 1 plus 30, or 1 plus 6. 5 does not equal 7. Womp, womp. So I have to go for 8. Okay, so our steps along the way. Did we square but not like a freshman? Naturally, if you goof that, the whole thing is crap after that. When that happens on test, I'm following the rest of your work. If you goofed up stage 1, but everything after that was still correct based off of the incorrect information, that's when you'll only see that 1 off. Okay? Get everything to one side. Did you square but not like a freshman? Did you get to the quadratic? Did you get to the correct answers by factoring or completing the square or quadratic formula, whatever your jam was? And did you find the extraneous? Okay. Now, let's say you squared like a freshman. Stage 1, oops. Maybe not even that. Maybe you called it negative 2x minus 12. Just, I missed a sign. Everything craps out after that. You get down to the quadratic. Did you follow it all the way to the end zone? Did you get your 2 answers? Check your 2 answers. They're both extraneous and write no solution. If you run it all the way to the end zone and it turns out it was just the wrong end zone, I'm still going to give you credit. Like, good job, Forrest. Okay? It would be 1 off because that's exactly where your error was. But did you take it all the way there, find your solutions, check your solutions, and show that it was no solution because your answers were extraneous? Okay? So, poke and poke. From the homie work, talk to me. For those that did it.
No, I don't know what he did. I know it's not the answer. I missed. Oh, yeah, hopefully that's nothing.
Nothing?
If you, like, square, so 12 over 2 squared, 6 squared.
All right. Then 2, 2. Okay, the last slide or so of section 2.1 was just more practice with the graphs, which I think we're okay with, and more practice with the radical equations. Again, this is the second or third time you've seen those type of radical equations. If you just need more practice, then you got more practice. You have the solutions. If you need more practice, then go to that section of the assignment. Pick something that looks ugly and kill it. Okay? So, polynomials. Well, yesterday and the day before, that was monomials. Monomial, 1 term. Polynomial, more than 1 term. Okay? Now, technically, a monomial is one of the polynomials if it still fits these criteria. So it's an umbrella term. You can't have rational exponents and you can't have negative exponents. But you show kids this and they tend to freak out. Okay. This is written in sequence notation. We use this to mean all of them, no matter how big. A sub 0. Not like sub-zero, but sub-zero meaning the 0th term, the constant term. So like plus 5. This is x to the, what's the degree on it? 1. So when they say a sub 1, that means the coefficient that goes with x to the first. The coefficient that goes with x to the second. That subscript, you've seen this, particularly our juniors, second semester chemistry, starting to talk all about those compounds and balancing equations and how many different atoms of different types you need to balance out your molecule. It's a subscript, meaning how many of them you have, H2O. I have 2 hydrogens to 1 oxygen. This is a subscript, meaning it's the second coefficient. It doesn't have a mathematical operator. It just says it's the second one. If I follow that ellipsis all the way back, this says, well, I don't know what degree my polynomial is. Could be to the 5th, could be to the 35th. But it's the coefficient that goes with the nth term. And then after x to the 35th would be x to the 34th. And the coefficient that goes with it. And then x to the 33rd, and the coefficient that goes with it, and on and on and on and on and on. That's why they write it this way. It means all the polynomials. Okay? Regardless of what n is. So, you know constants, you know linear, you know quadratic, they're all examples of polynomials. A polynomial has to meet these criteria. Continuous for all real numbers. That is definition. There are no gaps in the domain for a polynomial. It's just squiggles. Okay? Continuous, smooth, rounded turns. Got some curves on it. Not afraid of eating a potato. No Amanda Seyfried. Okay? It's not a stick. It can't have that sharp bend in it like an absolute value. Okay? Continuous and no sharp corners, no asymptotes. And then what it does here is really dependent on the characteristics of it. And that's what we get for the next couple of sections is, y'all remember, chapter 5 of Algebra 2 is the heart and soul of Algebra 2. It's where you deep dive on polynomials. We review quadratics, and then we introduce you to imaginary numbers. And now that you know that, we go into polynomials, and everything is, all right, you got big ugly? Awesome, turn it into quadratics. Kind of like in geometry, you spend so much time on triangles because every other polygon can be turned into triangles. We spend so much time on quadratics in Algebra 1 and 2 because every polynomial can be turned into linear and quadratic factors. Which is why we say you better be able to quadratic. Okay? So, first up, transformations. What is that 5 spot in? A, B, H, or K? If you have to go back and look at section 1.5 notes for your holy grail of transformations. Oh, sorry, the 2, not the 5. The rest of the family's sick. I'm sleeping like crap and getting up 3 times a night. Sorry. Okay. Okay, that is in the H spot, yes. Okay. It's just the pool bug. You ever go to the pool and just get sick because stuff in water and around people? The rest of the family, sick. Not the guy who works in a petri dish because my immune system's on turbo from being around kids sniffing and snotting all the time. That is the H spot. It is my horizontal translation. Remember, it's bass-ackwards land. So it says I'm going to go to the right 2. Do you... That way. I go that way. Ugh, that way. And then I'm just going to use... I can use square steps. I can use cube steps. That means I can also use perfect fifths. I'll have an inflection point in the middle. What is 1 to the 5th? 1. What's negative 1 to the 5th? Negative 1. What's 2 to the 5th? 32. So this thing takes off in a hurry.
Wait,
Okay.
why is that? Oh, so you just go 2 this way from the.
Yep. I go 2 to the right, up 32. 2 to the left, down 32. The same way that I would with cubes. If that said x minus 2 to the 3rd, I would go over 1 up 1. Cubed is 1. Over 2 up 8, because 2 cubed is 8. Well, now it's to the 5th, so I'll go from here over 2 up 32. Okay? Now, if I can't fit that on here, maybe I change the scale. Okay? I've got 10 boxes in each direction to work with. I want to go to 32. Tens? Well, no, I could do tens. Right? What's 3 to the 5th? Radiating disappointment.
243.
So even that wouldn't fit on there if I went by tens, going just out 3 from my inflection point. So maybe I'll just say by, I don't know, I'll go by 3s. And so I'll go over 1 up 1, over 2 up 32. Back 1 down 1. Back 2 down 32. Okay. Sometimes you got to go a little bit off-road. Someone usually asks, how many points should I have on each side? Do you remember what we said?
Just enough to get a shape.
Enough to get the curvature of it. And it's really hard to get it with only 3 points in the middle, because 3 points makes a line. So again, 5 points for these, your inflection or vertex, and then 2 on either side, so you can see what the curve looks like. Okay. So what's a even polynomial gonna look like? Remember?
Isn't it given more of a back or like?
Yep. If it's a parabola, it's like this, and then as they get older, there's a little more junk in the trunk. As this gets up to 4th, 6th, 8th, that bottom of the U really thumps down. Okay, starts sagging a little. Okay, so I go up 1. I see a negative in front, so I know it's a vertical reflection. And I'll use to the 4th. So 1 to the 4th is 1. So over 1, down 1. Over 1, down 1. If I go over 2, what is 2 to the 4th? 16. Okay, over 2, down. Even that is so far off track here. Okay. If you can go enough off-road to hit 16, great. If not, yeah, change the scale. Go by 2s. So over 1, down 1, over 1, down 1, over 2, down 16. So here's 2, 4, 6, 8, 10, 12, 14, 16. Okay. You see how it's got a little more of a base to it. It's more of a U and less of a V. Okay. All about that base. So this is just, can you graph it? I would like you to be able to graph it by transformations and not just rely on the calculator, but If you have to use the calculator to ensure that you're doing it right, then go ahead. Use your resources. There you go. Graph 2 of them. See if you can do it by transformations first, and then confirm your suspicions with the calculator. You may need to alter the equation to look the way we normally have our transformation form. Let me figure it out. Okay, part A, don't overthink that. Just swap the terms so that it looks normal.
So you just have to have 5 points.
I would say 5, yep. Your inflection or vertex, and then 2 on either side so you can see the shape of it. Okay, I've said it in here enough times already. My Algebra 2 kids heard me bang this drum all semester long. You should know your perfect squares through 20, cubes through 10, fourths through 5, as many powers of 2 and 3 as you can possibly memorize. Not saying you have to know those, but boy does it make life easier. The same way that factoring quadratics was easier if you knew your multiplication facts. Okay. I cheated and went a little bit off-road for this one. Okay. Got a vertical reflection, vertical translation up 4, use cube steps. Up. 1, 2, 3, 4, 5, 6, 7, back. Go by 2 so I can fit everything. 1 to the 4th is 1. 2 to the 4th is 16. And again, you see it's going to be parabolic shaped. And it's got a little more U to it at the bottom. Okay? You also see why I say you should have the points on there, actual points marked, because let's be honest, some of us aren't the greatest at drawing. But if I see the points and you attempted to make something curvy through it, okay. It's kind of like when we were doing sets. You know how many of you I just saw this? Like, If it ain't a 3 and it's kind of squiggly, all right, it's a set bracket when it should have probably been more like this. Good enough, right? If you have the points on there, then I know that you're at least trying. Okay? It's kind of like those. Remember practicing your letters? Okay, that's what those points are for. They're your guide. All right? My kid's 4. We're doing that all the time now. He gets excited whenever he sees the letter P. That's my name! Yes. Yes, child. Okay? So, I talked about this a little bit before with our monomials. Remember with our monomials, if we had an odd or an even power, if we had a positive or negative coefficient, it led to a certain set of characteristics. The same thing holds for all polynomials, it's just what happens between the ends changes. Okay, if I have a positive odd polynomial, okay, so like a positive 3x to the third, a 2/3 x to the fifth. If I have a leading term like this, I know we're going to start with, as I go to negative infinity, my y's go to negative infinity, it'll do stuff and then end up at positive infinity. Okay? That's the leading term test. Now, what it does in the middle entirely depends on how much stuff comes after that. How many other terms? I might have a quintic that just looks like this. I might also have a quintic that looks like that. It depends on the other terms in it. But if I just look at the leading term, I know that it's going to do that. Okay? So this entire page could be summed up chart style. If I have ax to the n, I should change that color. There. Ax to the n as my leading term. If I have a is positive versus a is negative, if I have n is odd versus n is even. Okay? That's just what the end behavior is going to do. What is in between those ends changes dramatically based on the rest of the function. But I at least know the end behaviors. Okay? Now, depending who you had for Algebra 2, I know that Mr. Spear and I were using pseudo limit notation. I don't know if Mrs. Work and Miss McCreary were. But the book, the actual book, used really childish notation. They called this an up and up function. Ew. Ew. No. No. We will say the limit as x approaches positive or negative infinity is positive or negative infinity. We'll use our limit notation for end behavior. No down and up function, okay? Don't, no. Okay. Now, the reason, okay, why would I need to complicate it with big words? I've had kids yell at me and say, stop using big words, you make me feel dumb. Okay? No. Appropriate vocabulary. How many times have you run across a problem and you know how to do the problem, but you had no clue what they were asking because you just didn't know the words? We are going to use the proper vocabulary and the proper notation so that we don't get just flummoxed by big words and weird symbols. Okay? So, leading term test. To do the leading term test, it has to be in the correct order. Y'all remember standard form? Okay, it's like the popcorn buckets at the movie theater. You have like child, small, medium, Merca. It's right. Well, I need to make sure that this is in standard form before I can do the leading term test. Is it? Okay. You want the big dog. Who's the big dog out front? Who's got the biggest exponent? So I'm going to say that there's a positive x to the even. You see how it says, what is the end behavior justify with the leading term test? If I write this, I've justified it with the leading term test. It's a positive x to the even. And that tells me the limit of my function as x approaches both positive and negative infinity is what? Positive infinity. Okay, that's all I need. Here's my end behavior. Here's my justification. Okay? I go to the next two. Who's the big dog? Right? This is not in the correct form. Now it's in descending order. Now it's in standard form. And I see a negative x to the odd. So that tells me the limit of g of x as x approaches negative infinity and the limit of g of x as x approaches positive infinity are, it's a negative odd, right? It's going to be up at positive infinity, down to negative infinity. Then it wouldn't be a polynomial. Remember that a polynomial cannot have rational or negative exponents. So as soon as I throw this in there, now this is negative. Now this means I actually at the end have plus 4 over x to the fourth. Now I've got asymptotes. Now it's not continuous, so it's not a polynomial. Okay. What about, I see the big dog. We have a positive x to the odd. So limit of h of x as x approaches, limit of h of x as x approaches. As I go all the way back to negative infinity, what's this thing doing? Downtown, negative infinity. As I go all the way to positive infinity, what's this thing doing? To infinity. Hand me on. Y'all see the new trailer? Yeah. And in that trailer, Buzz is the chattest Chad that ever did Chad. Like his jaw is literally like a block. All right, do these two. Yep.
Senior quote. The chattest Chad that ever did Chad.
I've had kids force me to put myself in the quote book before.
So it's either that, like a Carl, you know. Oh, you know. Wasn't that him with the first day too? Very close. Carl like a Spears room. Or Nepal.
Anytime you need somebody for a problem, you use Carl. Like
Cacarl.
Carl.
Okay. Mm. Okay. Okay, not very difficult. It's just look at the thing, it tells me the stuff. I have a positive x to the odd, which tells me as we head back to negative infinity, this goes to negative infinity. As I head up to positive infinity on the x-axis, my y's likewise go to positive infinity. I have a negative x to the even. Tells me that as I head to both negative and positive infinity, headed downtown to negative infinity. Okay? So, leading term test. A lot of what we're going to do in the next couple of days is reviewing this stuff from Algebra 2, where we learned characteristics of polynomials. I should be able to look at a polynomial and just tell from, all right, leading term, I know it's going to be here and here. Constant at the end, I know it's y-intercept. This type of factor and this type of factor, I know all of my possible rational factors. Remember Descartes' theorem, law of sines, okay? All of that kind of stuff, rational root theorem. I can narrow down my options. What if I turn it into a bunch of factors? Now I know my zeros. What does it do with each of those zeros? Well, it depends on its multiplicity. All of those things about polynomials are characteristics. I can break it down. This is just the first stage. Speaking of, there's a bunch of stuff. Zeros and turning points. You learned the fundamental theorem of algebra. It says, if I got a degree n polynomial, how many zeros does it have? Whatever n is, right? If it's x to the fifth, it's got 5 zeros. They might be real, they might be imaginary. They might be rational, they might be irrational. But I've got 5 of them. Okay? More specifically, in this case, if I have a degree n, I got degree 6. That means I have 6 possible real zeros. And then I go and look at it, and well, clearly it doesn't have 6 real zeros. Curiosity, how many real zeros does it have? Well, it does have 3, but do you remember multiplicity? There are 4 real zeros. It went through like a line. So it happens once. It went through like a line. so it happens once. It bounced off like a parabola, so it happens twice. Okay? And then I've got these turning points that are not near my x-axis. So that means I must have some imaginary zeros. And I would have to find them using all those algebraic tricks that I learned last semester or last year or the year before, whenever Algebra 2 was. Okay? So that's my zeros and turning points. If I have a degree 6 and I have at most 6 real zeros, the turning points is always one less than that. If I got 6 possible real zeros, I've got 5 possible turning points. It's always one less. If I know that something is a 0, we talked about this with our parabola review. Remember, zeros and x-intercepts and roots and solutions, they're all talking about the same thing, but in a different context. If I know that C is a 0 of it, then I know that C is an x-intercept. It's an x-intercept because it's when y is 0. That's why we call it a 0. If that is a 0, it's also a solution. If it's a solution, then I can always have x minus the 0 as a linear factor. Now sometimes, remember, we got some pretty ugly answers for these. Remember, you'd get complex numbers, compound numbers. If I have something like my solutions are 1 plus or minus square root of 3 over 2, then that means x minus 1 plus root of 3 over 2 is a 0, or is a linear factor. And x minus 1 minus square root of 3 over 2 is also a linear factor. See, over here, we're used to seeing nice things like x minus 5. 5 is one of my zeros. Oh, we also got those too. I said, PreCalc starts by picking up where Algebra 2 left off and dialing it up to an 11. This is going to be the norm now. Okay? You got to know your Algebra 2. Come on now. All right. Quadratic form. Do we need to get that yet? Yeah, we'll talk about that now. Quadratic form, maybe you've heard it called as the U method. It's when something looks like a duck, it quacks like a duck, it turns out it's a goose. Okay? Quadratic form is when it looks like a quadratic. I can even factor it like a quadratic, but it ain't x squared in the front. I might have something like x to the 4th minus 5x squared minus 14. Okay? It depends on the textbook, A method or U method. I think most books will actually use U because A is the coefficient of that first term. So I would see this and say, all right, my middle term is the square root of my leading term. And then I got a constant. So I'll just pretend this is U. And this is U squared. And then I'll factor that. U minus 7, U plus 2. And then I'll go back and remember, wait, it's not actually U, it's x squared. Okay? So it looks like a quadratic. I can work with it like a quadratic, but it's not actually a quadratic. I keep going. Now I can set each of these equal to 0 and solve. Plus or minus square root of 7, plus or minus I root of 2. Okay. So quadratic form was something that we encountered before. When we're dealing with polynomials, it's usually not a big deal. Most of us are okay factoring it as is. Where it gets dicey, do you remember maybe with exponential and logarithmic equations? E to the 6x minus 5 e to the 3x minus 14. That looks a lot bigger and uglier. But if I recognize that my middle term is the square root of my lead term, I can call it u squared minus 5u minus 14. Go ahead and factor it, and then at the end, I'll replace those u's like this. And that'll help me start solving. So with polynomials, it's not as big of a deal. When we review our exponential functions in chapter 3, then this u method might be a little more pertinent. Okay. Y'all cool with the graph thing? Like the leading term, test, I can graph things, hopefully. End behavior, plot by points, all that. Okay. Zeros of the polynomial. If I want to know the zeros, I got to get it in a factored form. Do you remember how to factor a cubic? The first stop on any factor train is look for a GCF, greatest common factor. This actually isn't that big of a deal because that's x squared minus 5x plus 6. That's x. I don't know why, but 6 really trips kids up. You sure about that? Isn't it -6 and +1? Why not? Because it's a +6. I don't know why, but whether that's a positive or -6 just messes with kids. Yes, it is x minus 2, x minus 3. And it says determine all the real zeros. Well, set this equal to 0. Set this equal to 0. Set this equal to 0. It was a cubic, so I had at most 3 real zeros and 2 turning points. I just found 3 real zeros. Ta-da! That's it. So now we're going to see who remembers factoring in all of its various forms. Get them. It ain't a test. Collaborate. Y'all weirding me out. Part B looks like a duck, it quacks like a duck, it lays eggs like a duck, turns out it's a platypus. Proof that nature has a sense of humor. Okay. X squared minus 5 and x squared minus 3. Do you remember how to factor difference of squares? What if that was x squared minus 25? Okay, so now it's x squared minus 5. I can still factor it. I'm just going to have radicals in there.
Yeah, isn't it just x equals plus or minus?
Not 5. Square root of 5. Okay, it's x plus the square root of this thing, x minus the square root of this thing, x plus the square root of this thing, x minus the square root of this thing.
If we just put plus or minus, does that make sense?
So my answers, you can't for the factored form, but for the answers, plus or minus square root of 5, plus or minus square root of 3.
Oh, so you factor it out.
The difference between solving by factoring versus, couldn't I also set this equal to 0?
So we can do that.
Yep. It just says solve by factoring. This, look, I factored. Okay? Now, we got to pay attention to the words again. Remember, yesterday I was saying if the directions say use a scatter plot, do I graph it on my paper? Make a scatter plot. Okay, now I got to put it on my paper. If it says by factoring, look, I factored. But if it says factor completely and then tell me the zeros, now I would need to go down to this instead. If it says factor completely or write the linear factorization of. Again, you got to know the vocabulary. It really sucks to get got by the directions. Okay? All right. So these are more examples of it's in quadratic form. I see a term that is the square root of the leading term in the middle, followed by a constant at the end. That's quadratic form. This could have been x to the 40th minus 3x to the 20th minus 4. As long as the middle term is half the degree of the leading term, followed by a constant, that's quadratic form. Which means I can factor it just like a quadratic. I can pretend that's just an x squared and x with minus 4 and plus 1. I just got to remember that whatever these x terms are have to follow the middle term. Like in a normal quadratic, don't you have an x in the middle, so you get x's to the first here? So I got an x squared there, that means I have an x squared here and here. I can now choose to do x plus 2, x minus 2, or I can say x squared minus 4 is 0, so x squared is 4, so x is plus or minus 2. Or set them equal to 0 and get plus or minus 2. Does anyone remember the sum of squares? What changes? Okay. What if I just set it equal to 0? Plus or minus 1i. So how is factoring a sum of squares going to be different than a difference of squares? Just throw an I in there. If this said x squared minus 1, I would say x plus 1, x minus 1. I'm just going to throw an I in there. 1i. Negative 1i. That's the only difference. Difference of squares, it's x plus or minus the square root of this. If it's sum of squares, it's x plus or minus the square root of this, I. It's just a shortcut.
If we don't have that negative 4 there, do we just take the x squared out of it and we just have x squared minus 5? Like if you didn't have the constant.
Oh, okay. So if this wasn't here at all, I'd take x squared out. I'd have x squared minus 3. This means I've got a 0, but there's 2 of them. This has x is plus or minus square root of 3. Yep. All of our same factoring rules. It's just stuff's going to get bigger. Now, a note that I want you to have right now, determine all of the real zeros by factoring. We're just going to ignore that line. We're big kids and we need the practice. Find all the zeros. Real or imaginary, compound, complex, rational, irrational, I don't care. We're going to find them all. And in that case, we had our imaginaries plus or minus I. Okay, we need the practice. So, factor them. You might have radicals as answers. You might have imaginary numbers as answers. You might have a table that's completely in the wrong spot. If you four could please move exactly one tile forward. There you go. Ah. That's better. Thank you. I still don't understand why we're whispering. Okay, first stop on the factor train is always GCF. Okay, quadratic form. Factor it just like a normal quadratic, but you're going to have x squareds in there. I can either set things equal to 0 and solve that way, or I can do difference of squares. Okay, whichever method you choose, you're still ending up with plus or minus square root of 3 square root of 6. Factor out x. Factor your quadratic form just like a quadratic. Again, I can set it equal to 0 and solve. Or I can factor by difference of squares, or sum of squares. X plus, be careful, square root of 8 is not square root of 8, it's 2 root of 2. Okay. Now I'm writing both up there because I want to emphasize again, I don't care which way you do it. The only time it's going to matter is if it says factor completely or write the linear factorization. Then you have to do the factoring way all the way to the end. But if it just says factor and solve without the word completely or linear in there, then I can factor the first part, set them equal to 0, and solve by square roots. Okay? It's just, right now it's a matter of personal preference. Later you may be forced to do one way or the other. Yes, and we talked about that, I think, like the second or third day of class. We got to be careful about which of those is the I in the radical.
Oh, in the radical.
Which one? Second one.
I can get all of them.
In the radical.
How many of you have neat enough handwriting to distinguish between them? Okay. Are you writing nice and clear like that, distinguishing where your radical ends and the I is clearly outside of it? Okay. That's why we usually write it like this, even though technically this is the right way. That's how you're supposed to put it. But this is the way we're used to because it eliminates that confusion. So, whoop. Repeated zeros. Sometimes things repeat themselves. Sometimes things repeat themselves. Sometimes things repeat themselves. And I have to know that means that the 0 occurs multiple times, but I don't have to say it multiple times. Okay, example, if someone asked, who was in your classroom yesterday? Matt was in my classroom in first period, and lunch, and Spartan time, and after school. Go Game Club. Finn was there too. Okay? Do I say Matt and Finn 4 times? Or do I just say they were in my room? Okay? So when I factor out my negative x squared, why would I want to do a negative x squared?
So you can keep positive.
Makes my factoring a little easier. Okay? And then I have negative x squared, x minus 2, oh, plus 2, x minus 1. This says x equals negative 2, x equals 1. This, if I set negative x squared equal to 0, technically it's plus or minus 0, like as I solve, but that doesn't matter, it's still just 0. And it happened twice. So I would just say 0. I don't say 0 multiple times. That's it. If it asks for the multiplicity, the way that the book wants us to write it is okay. That's the technical way to write it. Y'all, I'm lazy. I'm just going to put a subscript on there and say there's 2 of them. Okay? That is not official notation. I've never seen that in any textbook. That is me just not wanting to write multiplicity of 2. Okay? Yep. So, factor them. Know that you might have repeated factors. You might have repeated zeros. You don't have to say the 0 multiple times. Okay? You just say it. You know, which students were in your classes this semester or this year? I'm not going to say Jaden and Brooke twice. Okay? They were just in my room. Yay. Okay, when that 0 happens twice, I don't have to say it multiple times. And be like, it's redundant. It's going up to Mr. Sire and saying, Mr. Dude, Sir, Sire. Okay, always start with GCF. Factor what's left.
Yeah, I had to go into it.
Okay. Particularly on part B, I've got repeated zeros. I don't need to say them 3 times and 2 times respectively. If it asks me for the multiplicity. Okay, now I have to say that. But it didn't, so I shan't. Okay. Missed opportunity for brownie points. I've missed the instructions on both this one and the examples above them. What did we forget to do? Okay. So it's really simple. If this says state the number of possible real zeros and it's a degree 3, possible real zeros 3, possible turning points 2. That's it. It's always one less. The turning points are always going to be one less than your possible real zeros. Because think about if I've got 3 real zeros on a negative cubic, that means I have 3 real zeros, but I had 1, 2 turning points. Okay? Even if that x-axis moves, say it was here, I still have 3 real zeros. This one just repeated twice. This happened once. I still have 1, 2 turning points. Okay? So for this guy, I see a x to the 5th positive. So I'm going to have 5 possible real zeros. And I'll have 4 possible turning points. See, I would have got 1 off on my own test. I didn't read the instructions. Didn't follow through. Okay? No directions on the test. I can just put words. Just words. Do thing. Read my mind.
Out of those 5 possible zeros,
Mm-hmm.
how do you obviously it makes sense, right? Because they're real. But if they're not real, then do we have to do it at the end?
Good thing we got multiple sections of this chapter. Yes, we'll find the real zeros and then use the real zeros to either long or synthetic division to get to the quadratic. And once we're at the quadratic, we can get the imaginary zeros.
What's the first?
We did last week was Monday was a test, Tuesday was FUBAR, Wednesday, Thursday, long weekend, Tuesday, Wednesday, Thursday, Friday test. Yep. Look them over. What do you think?
I think we're good. That's like a 4 numbers. Yeah, why
Do you remember factoring by grouping?
Yeah, it's right.
Get it! Get it! Show me you remember.
Over the last 5. Like the quiz, whatever vocab you want me to use.
I take the derivative of it and just
Only if you can factor it first. Mmm.
Oh, that's not the problem. So what did you say for the possible
I wanted a picture of that and to put it on a t-shirt. The look on Jaden's face, just like, it was so meme worthy. Oh, okay. The whole reason that we split our middle term in the AC method of factoring is so I can factor by groups. These two got an x squared in common. These two have a -1 in common. Remember that? Altogether, they both have an x minus 3 in common, so I'll take that out, leaving x squared minus 1, which itself is a difference of squares. So x is 3 and plus or minus 1. Maybe we just, it's been a while. Okay. Why is what the square root of 1?
I'm done. Problem quits for the day. Now he's like 5 more problems. Let's go.
No, I'm gonna smack Anna with a pool noodle. Being mean to yourself. Knock it off.
Don't we have because that's real.
Say again. Hey, everyone, shut your holes. I can't hear the question.
Oh, there's 3 reals with this.
Okay, never mind.
But don't have to do the possible.
I was just asking if you could factor it.
Oh.
Like, the directions say go ahead and do all the stuff. I wanted to see if we remembered how to factor. Because it was x squared minus 1. Okay. So, and then multiplicities and graphing, that's a good place to stop.